We started from a small two-wheeled robot, differential steer. This is probably the 7th or 8th version of OzBot that we've developed. As we've progressed, the technology and the capability of the system has increased significantly. A lot of that's been as a result of the input from the law enforcement officers and people from defence saying that they want certain capabilities with the systems, and us trying to achieve that within a budget and also trying to keep the system reliable. So some of the systems which are used at the moment are in order of sort of $250,000 Australian dollars to up to around the $1 million marks. The OzBot is sitting more around your family-sized car sort of price range than that. So if something does happen to it, if it gets blown up, if it gets damaged, if it gets driven over, then it's not the same sort of cost to replace. So the guys can be not careless, but certainly they can maybe take more risks with the system and get more bang for buck at the end of the day. So originally we spoke with the local law enforcement authorities about developing a small to lightweight mobile platform that they could use as a first responding system. Basically, when they get out on a job, they need to get good situational awareness so they can plan and make the moves accordingly. The systems that they have currently are fairly large, bulky, heavy, and take a little while to start up. So what we were trying to do is develop a system which is small, man-portable, and could be deployed quickly and give them a good idea of what's downrange, quick smart. The OzBot system consists of two major components. There's a controller which an operator uses to drive the platform and the platform itself. The controller shows a live video stream and two-way audio from the robot so that they can see and hear anything that's happening around the robot, as well as speaking to anyone who might be in the range of the robot, so you can have a conversation and so forth remotely. The robot itself is made up of a differential drive tractor system and the main chassis, which houses all the control electronics, the drive motors, the batteries and the communications equipment. So my responsibilities on the OzBot project are to do mainly with the circuit design and 3D modelling of the system. So I'll speak with the other guys who might be focusing on the programming side of things or some of the communications, and work out how we can make all these systems talk to one another, fit together, make sure they're sort of talking on the same, speaking the same language. The OzBot platform as it stands is a human-in-the-loop system, which means someone needs to be there controlling it at all times. However, we're working on increasing or introducing a level of autonomy whereby the user might say to the robot or instruct the robot to go closer to a door or drive around the corner, then wait the next command. The next level on that is full autonomous systems, where you may have a robot driving around looking for key objects or identifiers and noticing any changes, and then it may alert a user or something like that. Next, I guess there might be a full interaction with humans, so you could give voice commands, tell the robot to do something. So for example, say you need to find out whether someone's in a house or not for a rescue operation, and it might be dangerous. They may be fired there might be a gas leak. For whatever reason, it's just not wise to send a person in straight away. So what you might do is strap a sensor suite to the OzBot, or to send the OzBot in itself and use the cameras to look around, investigate an area. Or you could use gas sensing equipment strapped to the OzBot, which sends environmental data back to the controller, so you can get all that information without actually having to put yourself in harm's way. You can send the robot down to do that work for you. The development process for OzBot has been a fairly big one. There's been a lot of involvement from obviously the team members within CISR, but also the input we've had from the various forces, from defence and also the police and so forth. And really it's been a fairly large developmental, evolutionary sort of project, with us trying to fit in as many of the good ideas that we're being presented with, and balancing that with the practicalities of having a small, lightweight, inexpensive system which we can deliver at the end of the day and hopefully people can get some benefit from.